Hi and welcome. I'm trying to learn particle physics. Today the standard model. And after we've done that, we're going to do grip strength training, and if you participate in the grip strength training, that's at your own risk. It took a little longer for quantum theory to tame the other forces. We had already more or less successfully described the quantum electrodynamics, the theory of quantum electrodynamics. And that was done by bringing together the... No, but that was the wrong thing. What was the problem? Okay, I'm confused about. It was more harder with quantum theory of the other forces. Where was it now? Thus, according to the theory of quantum electrodynamics, two electrons repel each other thanks to a photon, the boson, that transmits the electromagnetic field. So, theory of quantum electrodynamics could explain the dynamic of the electrons, which are quantons, and they are repelled, V6 in this fermion, by a photon which is transmitting the electromagnetic force, which is all the happening inside the fermion. And it comes from nowhere and it goes into nowhere. Electromagnetic field that appears from nowhere and passes from one electron to another. It appears from nowhere and it passes from one electron to another. And an infinite series of such virtual particle fluctuations to shift properties of classical or bare electrons by tiny amounts. And that they are pushed from left to right, that shifts their properties a bit. And since the 1940s, that could be with accuracy confirmed in experiments. Now, and it took a little longer for quantum theory to tame the other forces. The weak nuclear force, that is one of the, well, there are three here named. What was it? Maybe it was here. Electromagnetism, weak force, and I'm searching for how to have quantum electrodynamics. Somebody said it. Okay. The weak nuclear force exists also, and was plagued by unruly infinities that made calculations of all but the simplest effects impossible. The way forward taken during the 60s by Weinberg and others was to mesh it up with electromagnetism into a unified electroweak force that manifests itself at very high energies such as those in the early universe. Okay, to be able to describe and put our theories how weak nuclear force is working inside the fermion, they put together the weak nuclear force with electromagnetism. And now we had electroweak force. And they were not able, and that was now like that one as it was in the early universe. Just as in the 30s, when Paul Dirac's merging of special relativity with electromagnetism predicted the existence of antimatter, this theory presaged particles that had never been seen. The massive W and Z bosons to transmit today's separate short-range weak force and the Higgs boson. Now we're going to read the whole sentence again. Just as in the 1930s, when Paul Dirac's merging of special relativity with electromagnetism predicted the existence of antimatter. In the 1930s, that was Paul Dirac, and he merged special relativity with electromagnetism. And that helped to predict the existence of antimatter. I don't know the word presaged. Maybe that means more than just prophesied it. I understand it in the way it's prophesied, but it could mean something else for nowadays. Now there was Paul Dirac, and in the 1930s he one day had the idea, I'm going to combine special relativity and electromagnetism. Maybe he had them both on his table sitting. They had special relativity, he took it, and then he took the electromagnetism and put them together. And now this theory, making something like that, presaged particles that had never been seen. And these particles which had never been seen were the massive W and the Z boson. And they transmit the massive W and Z bosons to transmit today's separated short-range weak force and Higgs boson. to transmit today's separated, short-range weak force. The weak nuclear force or the electroweak force? Or no. And the Higgs boson. Okay, there are this W and the Z boson, and also there's somewhere with Higgs boson. And they are also transmitting a force, maybe from electron to electron, like it has happened with the electrodynamic, where a photon, which transmits the out of nowhere coming electromagnetic field and repels the electrons V6 and changes by a tiny bit their properties. The Higgs was needed to ensure that during the breakdown of the unified electroweak force, the W and Z particles acquired mass, confining the weak force to atomic distances, while the photons of electromagnetism didn't, allowing them to slip across the universe. Let's read the whole sentence again. The Higgs was needed. So the Higgs boson. There are different types of things in it, and there's a Higgs boson. And that Higgs boson was needed to ensure that during the breakdown of a unified electroweak force, the W and Z particles acquired mass. Did they now split it again, this electromagnetism and the electroweak force, this nuclear weak force up again, but they try to keep the W and Z particles? They acquired mass? Whatever. And the Higgs boson was needed so that when this electroweak force then again broken down from the previously unified one, that the W and the Z particles inside of the whole thing have more mass, and they keep that acquired mass. Confining the weak force, I don't know the word confining, and I think I should know it. Confining the weak force to atomic distances. I don't understand this. Maybe because I don't know the word confining. While the photons of electromagnetism didn't. Okay, it was when splitted up, this electroweak force, W and Z particle acquired mass, and that stayed so. And the weak force kept on atomic distances. But the photons of electromagnetism didn't. Now they compared electromagnetism and electroweak force. The electroweak force was split again, but we acquired mass through that on the W and Z particles, which were done onto them to combine with the electromagnetism force, was done away in the distance, but the photons of the electromagnetism didn't keep the distance, and were allowing them to zip across the universe. We're zipping across the universe. I'm not familiar with the word zip. Now we're crossing now through the whole universe. We're going to stop here. We're 8 minutes in. We have a little bit more, and when we have quite something more, we will continue in the next part. If you were here for the standard model for dynamic particle physics, you can go directly to the next video. We will do now the Gripstrength training. And the arms next to us, we're doing the spotlight. If you participate in the Gripstrength training, let's sit down. We bring the fists down and up. And again down. And up. And now we're doing the flashlight. Fists to the inside. To the outside. Last time. Now we're doing some big arm circles. Bring the arms up, flat hands, stretch them also a bit. Bring the arms wide back, bring the arms down and back. And again up, stretch the hands far, wide, back and down. And now the other way around. Reach high back, high up, and in front, but stretch with the arms. So the arms also back, and in front. Now make fists, and we're going to do outward circles with the wrists. Now we're doing again such an arm circle, and the second one. And now backwards. Change also the direction, which you're doing with the fist. And backwards again. And the next exercise, the frog anxious to the fever. Go to stand set. Hands next to us and bring the hands down with flat fingers. And up with strong fists. Again down with flat fingers. And up with strong fists. Down with flat fingers. Up with strong fists. Last time down. And up. Next exercise. The arm ups, make strong fists and bring the fists into flexion. Now bring the arms out and the wrists into extension and have flat fingers. And up, strong fists, flexion. Out into extension with flat fingers. In, strong fists, flexion. Out, strong fists, extension. And that was the last time. And we're having already the last exercise, the unfolding rocket boosters. Long arms, strong fists, and bring these fists to the inside, the flexion. Or to the outside, extension, flat fingers. To the inside again, strong fists, flexion. To the outside, extension, flat fingers. Last shot, to the inside, strong fist, flexion. To the outside, extension, flat fingers. And bending again. Now we're going just with moderate pressure over the middle part of the lower arm to relax the extension to the toe muscle. And on the other arm. And that was the grip strength training. I thank you very much and next time.